In this lesson, we look at further areas of composite circular shapes. These are shapes that have got circles in them, but are also including other different types of shapes. So for this example, we're going to find the shaded area, which means we're going to have a circle, and we've got this space inside that we need to remove to find out what the area of the shaded part is. Now up here we have some hints, and the first is that we find and label the length of all the sides. Secondly, we break it up into workable parts, and if possible use a formula to help us with the substitution and solution, and then we add or subtract areas as needed. In this case, if we can work out the area of this hexagon, six-sided figure, and subtract it from the area of the big circle, we're going to have the answer. This is shown in the diagram next to us. I'll just push this up a little, and you can see here's the circle, which represents this one here. And what we've done here is we've taken the hexagon and broken it into a trapezium, which will times by 2 to work out the total area. So let's work this through. First of all, we'll look at A1. Now A1 is going to be the area of our circle, and therefore we'll use pi r squared as our formula. Now r in this case is 9 meters, and pi we're going to use 3.14 instead of our calculator pi for this question. So it's going to be 3.14 times by our radius of 9, and we multiply that together because it's squared, and we come up with our solution of 254.34 meters squared. Now our second area we'll call A2. So this will be A1. Our second area, A2, is going to be the area of a trapezium. The area of a trapezium is half times the perpendicular height between the two parallel sides, and then it's times by the sum of the length of the parallel sides, this side and this side. Now if you look at this carefully, we can see that our height here is 7 meters. Now the length of this line here is 11, and the length of the other one is 2 lots of 9, so that would be 18. And we can get all that information from here because this is 9, so that's 9 across there, and that distance is 7. So there it is there, we've just turned it upside down. And our final value then for this trapezium here is, what we've got here is half of 203. So we'll put here half of 203. Now our total area has to be 2 of these, so that area of B must be half of 203, and we're going to times this by 2, and we come out to 203 square meters. Now that's not our final solution. All we've done now is we've worked out this full area here, and we know the circle. So to find the shaded area of the shape, the shaded area of what's remaining, that's these little bits here, we just have to take the area of our circle, which is 254.34, and we need to subtract from it 203 meters, that's the area of our hexagon, and we get a final value of 51.34 square meters as our answer for that shaded portion.